when you find out what chaos engineering really is. Fail fast, learn fast, but don't fail twice for the same reason. So you're moving to microservices and you're embracing the DevSecOps principles to deliver continuously small incremental changes to move at the pace of relevance. That's great, but how do you know you're resilient and what are the critical services and components of your system? Was testing your answer? Well, of course, you want to confirm how your system is behaving thanks to unit testing, integration testing, and end-to-end testing. But there's more. You want to actually find out how your system is behaving when things start to go wrong, and they will. You're going to find latencies between services, or maybe an entire region is going to crash. The fact is, if you're moving to cattle with ephemeral containers, infrastructure, and platform, you only have one way to demonstrate that you're getting there. You shoot them behind the barn multiple times a day and see how your system is behaving and whether or not it remained up and running. Welcome to Chaos Engineering. Chaos engineering is about experimenting on a system to build confidence in your system's capability to withstand turbulent conditions in production. You observe your system, you make a hypothesis about how the system would behave under certain failure conditions, you inject the failure and collect data to prove or not your understanding. You repeat and repeat and continuously increase your resiliency and your system's maturity. It is all about your ability to tolerate failures while still ensuring adequate quality of service. We'll do a video also on SLAs, SLOs, and SLIs. This is often generalized as resiliency. Unfortunately, development teams often fail to meet this requirement because of different factors, maybe because of short deadlines or lack of knowledge of the field. It's important to realize that chaos engineering is not just for your application layers. This can be used to achieve resiliencies against infrastructure, network, and application failures. So let's take a look at the history of chaos engineering. While overseeing Netflix migration to the cloud in 2011, Greg Holtzell had the idea to address the lack of adequate resilience testing by setting up a tool that will cause breakdowns in their production environments. Move from a development model that assumed no breakdowns to a model where breakdowns were considered to be inevitable, driving developers to consider built-in resiliency to be an obligation rather than just an option. Here's what he said. At Netflix, our culture of freedom and responsibility led us not to force engineers to design their code in a specific way. Instead, we discovered that we could align our teams around the notion of infrastructure resiliency by isolating the problems created by server notarization and pushing them to the extreme. We have created Chaos Monkey, a program that randomly chooses a server and disables it during its usual hours of activity. Some will find that crazy, but we could not depend on the random occurrence of an event to test our behavior in the face of the very consequences of this event. Knowing that this will happen frequently has created a strong alignment among engineers to build redundancy and process automation to survive such incidents. Without impacting the millions of Netflix users. Chaos Monkey is one of the most effective tools to improve the quality of our services. Now, by regularly killing random instances of a software service, it is possible to test a redundant architecture to verify that a server failure did not noticeably impact your end users. So that's great, but what are your chaos engineering options? Well, first there is Chaos Monkey, the tool invented in 2011 by Netflix to test the resiliency of its IT infrastructure. Like we talked about, the concept is to disable production systems to test how the remaining systems respond to that outage. Chaos Monkey is part of a larger suite of tools called the Seaman Army, designed to simulate and test responses to various system failure and edge cases. The code behind Chaos Monkey was released by Netflix in 2012 as open source. Now the Seaman Army has a broader set of tools to be able to also assess the resiliency of your entire infrastructure. For example, Chaos Kong drops a full Amazon region. Chaos Gorilla drops a full Amazon availability zone. And finally, Janitor Monkey cleans up after the destruction. Now, there's also commercial options to you with a company such as Gremlin. Gremlin was founded by former co-leaders from Amazon and Netflix that were responsible for fixing global outage. They built Gremlin to help companies harden and prepare services for internet scale. The Gremlin Chaos Engineering platform was created to proactively improve reliability and build resiliency to failure, to maintain customer trust and improve incident response. From game days to applying chaos engineering to Kubernetes, Amazon, and more. There you have it. You want your system to be highly available and resilient. You want to proactively emulate the issues you're going to be seeing in productions and proactively address and fix those before they actually happen. While you start chaos engineering in development, testing, and staging environments first, it is essential you understand that you must apply these capabilities to your production environments as well, because those are the only environments that truly represent your desired state with your real data and your actual scale. Let's be clear, all systems in the universe, yes, including space systems, must embrace chaos engineering capabilities and principles to ensure that your system has the resiliency and maturity it needs to be up and running and stable. But more importantly, so you don't wake up with a hard awakening. Putting your hand in the sand does not work. Proactivity is key.